So I'm Jordan Swanson. I'm the engineering manager here at Edgerton. So as a team, we're responsible for all of the construction, GPS technology stuff, the design models, all the quantity takeoffs. So I manage the team that does all that. I've been here for 14 years, so it's been a great place to work. So Edgerton started with GPS technology back in the early 2000s. So 2003, we had a small subdivision project. So we purchased our first D6N dozer with a GPS system equipped on it. So at that time, it was Jeremy Craven was kind of spearheading the implementation of GPS at the company, and Randy Hankey was the dozer operator that, he volunteered to kind of be the guinea pig of how this is going to work. So Randy's still at the company. So that was 2003, so he's still at the company today. He's a great dozer operator for us, and Jeremy's actually one of the owners now. So then 2004, we had the Marquette Interchange project, and so that project we bought our second D6N dozer with GPS. And during that project, and kind of in this whole beginning phase, we only had satellite signals for like 6 hours in a day. So you'd get like 6 satellites for 6 hours. And so you kind of had to start coordinating and scheduling your work around those windows of operation, right? So you could you're only getting signal for 6 hours, so you need to make sure that those 6 hours were gonna be when you need to finish grade stuff. 2005 was when we first had a GPS excavator, right, in the fleet. And it probably wasn't until 5 years ago that became like even standard for our industry. So dozers were very much an early adopter. Everybody was buying dozers with GPS, but to get it to the excavators was something that the industry took a long time to do, because they just figured, well, dozers can push to excavators and we don't need the excavator having the GPS. When we put it on excavators, though, what that led to is it led to us then fully modeling out our building excavations. So again, I don't think a lot of other people are doing that. I think at this point, people are sending out bottom of footings, like here's the pad, this is the exact size of the pad, and this is the bottom elevation. Whereas our designs, we'll put the overdig in that the GC needs for their form work, and then based on soil types and OSHA excavation standards, we'll model out the full excavation with proper benching and sloping and making it safe for the whole job. So fast forward to today, we have 27 GPS dozers, 26 GPS excavators, 1 GPS motor grader, a sheep's foot compactor has GPS on it, skid steer attachments have GPS on it. We have 14 handheld GPS rovers and 4 robotic total stations. When you use GPS machine control on projects, there's a lot of different benefits that you get with that. There's the obvious ones of you no longer have a person out there setting grade stakes anymore, so you've eliminated that person from a safety standpoint. And then they're setting rows and rows of stakes. The dozers come through, knock them all down, set them all up again, right? So you eliminate the need to do that. And then some of the other advantages are, instead of only having information where the stake is, the operator of these machines, they have information over every square inch of the project. So there's nowhere that they go on the project where they don't know exactly how far their dozer blade is away from the grade that they're trying to build. So that just gives a lot more flexibility to the operator of knowing how they need to build the job and maintain drainage. But in order to support that, you have to have a team in the office that builds these projects digitally before there's ever a bucket put in the ground. And so through that process, there's always going to be some errors with the designs and conflicts and stuff. So you're able to find all those errors, all those conflicts during the beginning of the project before you have any crews sitting and waiting and things like that, right? So you eliminate a ton of that just wasted time, which ultimately leads to fights with the general contractor of, I had all this standby time, now you need to pay me. You just clean up all sorts of stuff like that. And then we're able to work with the GCs really closely. If they have a logistics plan and they need their cranes to go here and there, we in the office can design grading for that in particular, so that it all kind of gets incorporated beforehand, so it helps planning and all those things. So we've seen a really large advantage is actually the ability to like plan and schedule and coordinate these projects before you ever have a crew on the ground. So that was one of the biggest things I think that GPS technology gave us. So at Edgerton, and another construction technology that we're utilizing is drones. And so I'm gonna go a little bit into like how we use drones, you know, because we can all go to Target and buy the $50 drone and fly it around and take pictures of our neighbors in their backyards, but that's not what we do. So the way we use drones is we'll define on the tablet, like we want to fly this area, map this area. The drone will go up, it'll fly a grid pattern, taking photos straight down with lots of overlap. And then through photogrammetry, we're able to create one unified aerial image and a topographic survey map of the area that we flew. And so I think of it as our own little Google Earth kind of thing, right? So we have imagery and surface elevation, and so that's how we use it. Some of the benefits of doing that is, you know, there's the old adage that a photo is worth more than 1,000 words, and so we've experienced lots of times where we'll go finish an area, topsoil it, it looks all great, we'll fly it with the drone, maybe we're gone for a couple months from the job site, we come back, the area is messed up, and we're asked to go finish our work, and it's like, well, here's a photo showing it was all done, so we can fix it. But so it's a way of just like, again, photos do way more than words and reports and things like that. And then like being able to calculate our quantities quickly and efficiently. I mean, you can fly an entire site, you could fly 80 acres in an hour, and to topo 80 acres by hand would be a whole day or more. And so we're able to do things a lot more efficiently with drones, and just it's giving our managers and our engineers and our supervisors more data at their fingertips to manage their projects better. So some other technologies that we've kind of invested in on the construction side is, you know, and maybe you don't always think of this as construction technology, but how do you price your work? How do you manage your work? How do you know that you're hitting the budgets that you estimated? And so there's a lot of enterprise softwares out there that you can buy and do these things, and they work really well. But you know, they were designed for an entire industry. They weren't designed for Edgerton in particular. And so we actually, a guy on our team, working with the whole Edgerton team, he developed our very own project management software, estimating and management software tool. And so we do all of our estimates in there. Once we win a job, it switches over to the project management phase. We can do time cards, quantity tracking, quantity reporting, and you get really live information on where you're at with your budgets and your costs. And again, it's about giving information at people's fingertips that are in the field, doing the work, making the decisions today, and they need information today. And so this is another example of how we're just like, we need to get our supervisors the information they need, so we built our own software to do that. Looking into the future of construction technology, and particularly in our industry, it's thinking of what's next. I think GPS technology and the other things I've mentioned, heavily important in our industry, and we're utilizing them daily. But trying to think about, well, what's next? What are the next big things? So looking out across the landscape of technology, I mean, there's remote control equipment, so you can operate 100,000 pound machines from a seat 100 miles away if you want, right? So there's remote control equipment. They're coming out with semi-autonomous equipment, fully autonomous equipment. So you have all of the big manufacturers, whether it's Caterpillar, John Deere, Komatsu, they're all trying to develop these autonomous things. And you also have a lot of third-party people also trying to develop these as like add-ons to CAT equipment or whatever, you know, brand you may be using. And so, you know, watching that technology, seeing how that advances, you know, will be really important for Edgerton to keep an eye on.